Okay, question 3. This is a slightly tricky question here. It's a nice little start with the first 2 questions. This one, not quite as pleasant. There's a bit more to do on it. So, when the pressure of a container of a gas increases, what happens to the particles? So, they hit the sides of the container less often. That's garbage. They hit the size of the container more often. Yeah, that'll work. Let's just see if there's a better answer. They move with lower speeds. That's garbage. Vibrate more energetically around fixed positions. This is a gas. That's garbage. So it's got to be B. It's always a good idea, though, to just rule out all the others first. Don't just pick one when you go through them in order. Okay, next part. A student investigates the pressure and volume of some trapped gas. So we can see they've got trapped gas here in that area there. We've got a pressure reading, and I've got a foot pump as they pump in the air, and that gas gets trapped. And then we can see that the scale, they've enlarged it here, and it says enlarge view. Then we've got a table, which has got the pressures and the volumes, and then it tells you the two multiplied together. So 100, this one here, times 28 equals 2,800. Okay, so we're pretty happy with that. It says, what should the student add to the headings of the table? Well, we can see we've got P, V, P times V, but it would have been nice to include the units, like pascals or newtons per meter squared, centimeters cubed. We don't know what they are. So add units to the heading. The next one is use figure 5 to estimate the volume of a gas for a pressure reading of 170. Well, 170 would be between these two here. So if we're after the volume, the best thing to do is to add those two together and divide by 2. And that will give us roughly what that value is. So we know that 170 is in between those two numbers, so the number that we want for volume must be in between those two. So that just says the pressure of 170 is between 160 and 180. We're now going to take the 18 and the 65, add them together, divide them by 2, equals 17.25. Now the important part is, don't write that down, we want the decimal places. So on lots of questions, you can just write whatever number comes up on your calculator. But if it asks you for significant figures, or if it gives you data, just match it. So we want to go to 1 decimal place, 17.3. Suggest 2 ways the student could improve the investigation. Well, one is we could have smaller divisions on here, so we're even more precise in our readings. Or I could repeat this again and again and again. I could have additional results and calculate a mean. They're the main 2 every time. Now remember, don't ever just say repeat it. You've got to say you repeat it and calculate a mean. You have to put the 2 of those together. The mark schemes as you go through a paper, that they demand both of those 2 statements. So any 2, use smaller scale divisions, ensure the temperature in the room is constant, and the next one is repeat the readings and calculate the mean. I think they're probably the best 2, but clearly we know that gas pressure depends on temperature as well. It says explain where the values in the column fit the equation. P1 times V1 equals P2 times V2. Now the reality is for this, you could say yes and give your reason why, or you could say no and give your reasons why. And all we got to do is just check, are these roughly the same? And I could make the argument, yeah, they are all roughly the same. Certainly at the start here, 2,800, 2,829. But we can see it goes a little bit ropey over there. So we could say yes, P times V is roughly 2,800, which agrees with P1 V1 equals P2 V2, as that should give a constant value K, 2,800. So lots of marks there for 3. Or, no, almost all the values of P are different from each other, except for P of 100 and 140. And it's use the values, use what's in your table to make your point, and the last values are not similar. So it looks tricky, but it's kind of just use some common sense, but make sure you are using the data in that table. Okay, and you can see there's lots of different ways I could have answered that there.